Hello, this is the Edexcel Foundation Maths GCSE paper from June 2017. In fact, the first paper was from May 2017, which is the one that we're looking at here. This is the non-calculator paper. I'm going to go through the whole paper, but I'll put timings down below so you can just jump to any particular question. If there's just one that you're stuck on, you can go straight to that. Okay, let's get started. Question 1 then, work out the value of 2 to the power of 4. Well, 2 to the power of 4 just means 2 times 2 times 2 times 2, which is 16. 2 times 2 is 4, times 2 again is 8, times 2 again is 16. Question number 2, write 7.26451 correct to 3 decimal places. So 3 decimal places, we are concerned with that third digit after the decimal point, the 4 in other words. And we are asking ourselves, is this closer to 7.264 or would we have to round it up to 7.265? Okay, so that third decimal point, does it stay as it is or do we round it up to the next number? And the way I think of it is as a number line with 7.264 at one end and 7.265 at the other. Well, halfway in between those two is going to be 7.264, right? That's halfway in between those two. Well, the number that we're talking about is slightly bigger than that. It's 7.26451. So just ever so slightly beyond halfway. Therefore, it's closer to 7.265. So when we're rounding it off, we would round it off to 7.265. Question 3, simplify 7 times E times F times 8. Well, the thing to know about these is that when we're multiplying things together, the order that we multiply doesn't matter. Okay, so we can change the order, and that's exactly what I'll do here. I'll put the numbers first, so I'll do the 7 times 8, and then multiplied by E, and then multiplied by F. So 7 times 8 is 56, and then we're multiplying that by E, and then by F, and the way we write that is without the multiplication sign. So we would just write 56 EF. That just means 56 times E times F. The second part then, x over 5 is equal to 2.5. Well, that x over 5, that just means x divided by 5. So you could think of it, I've got this number that when I split it up into 5 parts, or when I shared it between 5 people, each of those parts was 2.5. So to work out what the starting number was, I've got to put those 5 parts back together. In other words, I've got to do 5 lots of 2.5. So 5 times 2.5. I've used the grid method to do that, but you may well have another method you use, which is absolutely fine. Whichever method you feel comfortable with. But if you do that, 5 times 2.5, well, 5 times 2 is 10. 5 times a half is 2.5, and if I add those together, I get 12.5. Question number 4, write 4/5 as a percentage. Well, you're expected to be able to convert some fractions to decimals just from memory, and a fifth is one of those that you're expected to remember. So you're expected to know that 1/5 is equal to 0.2 as a decimal, and therefore 20% as a percentage. So if 1/5 is 0.2, then 4/5 would be 0.8, which is equal to 80%. So 4/5 is 80%. Question number 5, work out 60% of 70. Well, this is a non-calculator paper, so the easiest way to do this is going to be to start by finding out 10%, and we do that by dividing by 10. So 10% of 70 is going to be 7. And then we want 60%, which is 6 lots of 10%, isn't it? If I do 6 lots of 10, I get 60. So 7 times 6 is 42. So 60% of 70 is 42. Question number 6. Sammy spins a fair 4-sided spinner. On the probability scale, mark with a cross the probability that the spinner will land on B. Well, it's 4-sided and it says it's fair. That means it's just as likely to land on any one of those 4 sides. So you can see that there are 4 sides. 2 of them are B. So 2 out of 4. In other words, half of the time it's going to land on a B. So we put the cross at the half there. And then the second part, on the probability scale marked with a cross, the probability that the spinner will land on F. There isn't an F on that spinner, so there is 0 chance that it could ever land on an F. So we just mark that at 0 on the probability scale there. Question number 7. We're getting into one of those kind of wordy questions now, aren't we, with lots of information. So let's just go through it. So Fahima buys 2 packets of bread rolls costing £1.50 each, 1 bottle of ketchup costing £1.60, and 3 packets of sausages. Fahima pays with a £10 note and she gets 30p change. She works out that 1 packet of sausages costs £2.30. Is she right? And you must show how you got your answer. So the way to show whether she's right or not is just to work out what we think is the correct answer. And so let's go through that step by step then. So first thing, 2 packets of bread rolls costing £1.50 for each packet, right? And then she also got a bottle of ketchup costing £1.60. Well, we know what they cost, so we could work out how much she spent on that. So 2 packets of bread rolls at £1.50 each. That gives us £3. And then if we add on to that the cost of the bottle of ketchup, which is £1.60, we know for definite that she spent £4.60. Then it also tells us that she got 30p change from a £10 note. So if we take 30p away from £10, that gives us £9.70. So we also know for definite that she spent £9.70. From that, we can work out how much those 3 packs of sausages cost. So she spent in total £9.70, and if we take away from that the £4.60 that she spent on bread rolls and ketchup, that gives us £5.10. So we know that those 3 packs of sausages cost £5.10. To work out the cost of just 1 pack, we need to do £5.10 divided by 3. I've just done bus stop, short division there to work that out, and that gives me £1.70. So the cost of 1 pack of sausages is £1.70. So she's wrong, and you need to be very careful with these that you write down that she is wrong. Okay, Fahima is wrong because each pack costs £1.70. If you do all of that working out and all those calculations, but then don't include a sentence saying that she is wrong, you will drop a mark. Question number 8, work out 5/8 multiplied by 3/4. To multiply fractions, really straightforward. You multiply the numerators, so 5 times 3, which gives us 15, and then you multiply the denominators together, which in this case is 8 times 4, which gives us 32. So we end up with 15 over 32. And then the second part, work out 2/3 minus 1/4. Well, when we want to add or subtract fractions, they have to have a common denominator. In other words, they've got to have the same number at the bottom. And we do that by multiplying them until they both have the same number. So we're looking for a number that 3 and 4 both go into, right? And they both go into 12. So if we multiply 3 by 4, we get 12. And as we've had to multiply that denominator by 4, we multiply the numerator by 4 as well to give us 8. So 2/3 is equal to 8/12. They are exactly the same as each other. We're just using different numbers to describe it, but they're the exact same size. Then we've got to do the same for the quarter. Well, what did we multiply that 4 by to get a denominator of 12? We've had to multiply it by 3. So we do the same to the numerator. Same to the number on the top. We multiply that by 3 as well. So 1 times 3 is 3. That tells us that a quarter is equal to 3/12. So 2/3 minus a quarter is exactly the same as 8/12 minus 3/12. And we just subtract those numerators. So we do 8 take away 3, which is 5. So we end up with 5/12. Question number 9. Sean works for a company. His normal rate of pay is £12 per hour. When Sean works more than 8 hours a day, he's paid overtime for each hour he works more than 8 hours. Sean's rate of overtime pay per hour is 1.25 times his normal rate of pay per hour. On Monday, Sean worked for 10 hours. Work out the total amount of money Sean earned on Monday. Right, so he's worked for 10 hours. If he works for 8 hours, that is paid at his normal rate of £12 an hour, but everything over that, he gets a different rate of pay, which includes this extra bit for the overtime. So of those 10 hours, 8 hours were normal pay, and then 2 hours of it will be overtime. So the normal pay, that's pretty straightforward. We've just got to do 8 times £12, which is £96. And then if we work out the overtime, well, he gets 1¼ times his normal pay. His normal pay is £12. So we've got to do 1¼ times 12. I'm just doing the grid method for that here. So I've got 1¼ across the top, 12 down the side. So 1 times 12 is 12. And then 1/4 times 12, you might find it easier to think of it as 1/4 of 12. It's exactly the same thing. 1/4 times 12 and 1/4 of 12, the same thing, right? So 1/4 of 12 is 3. Let me just add those two together, the 12 and the 3. So that is £15. So he gets £15 per hour for each of his hours of overtime. And he did 2 hours of overtime. So 2 times 15 is £30. So his pay for those first 8 hours was £96. He earned another £30 of overtime. So the total is £126. Question number 10. A farmer has 20 boxes of eggs. There are 6 eggs in each box. Write as a ratio the number of eggs in 2 boxes to the total number of eggs. Give your answer in its simplest form. The way I'm going to do this is to work out the number of eggs in 2 boxes and then the number of eggs in 20 boxes, and I'm going to compare them to each other, and that will give us the ratio. So the number of eggs in 2 boxes is just 2 times 6, which is 12, and the number of eggs in 20 boxes is 20 times 6, which is just 10 times bigger, essentially, isn't it? So that's 120. So the ratio then of eggs in 2 boxes compared to the total number of eggs is 12 to 120. Both of those numbers are multiples of 12. In other words, they can both be divided by 12. So if I do 12 divided by 12, I get 1. If I do 120 divided by 12, I get 10. So that tells us that the ratio is 1 to 10. Question number 11. A sequence of patterns is made from circular tiles and square tiles. Here are the first 3 patterns in the sequence. And then the question is, how many square tiles are needed to make pattern number 6? So there are different ways you could do this. You could just keep drawing out that pattern. Once you can see what's going on with the pattern, you could keep drawing those out and count them up. I think it's easier to kind of work out what the pattern is numerically, right, using numbers. So in the first pattern, the squares are, well, I've just got 1, haven't I? In pattern number 2, the number of squares, I've got 2 across and 2 down. So that's 4 squares. In the third pattern, it's 3 across and 3 down, giving me a total of 9. In the fourth one, it's not shown there, but if there was, if we drew it, it would be 4 squares across, 4 squares down, which would be 16. In the fifth one, it would be 5 squares across, 5 squares down, so 5 times 5. That would be 25. And then in the sixth one, which is the one we're being asked about, it would be 6 across and 6 down. In other words, 6 times 6, which is 36. The second part, how many circular tiles are needed to make pattern number 20? Well, it's not realistic to draw out 20 of those patterns, so we need another method for this one. I think what I would do is I would make a note of how many circles there are in each of the patterns, and then see if I can spot the pattern and work it out from there. So in the first pattern, or in pattern number 1, there are 4 circles. In pattern number 2, there are 8. In pattern number 3, there are 12. It looks like they're just going up in 4s, doesn't it? So for that pattern number 1, it's 1 lot of 4. For pattern number 2, it's 2 lots of 4. For pattern number 3, it's 3 lots of 4. Therefore, for pattern number 20, it's going to be 20 lots of 4. 20 times 4, in other words, which is 80. Part C, Derek says when the pattern number is odd, an odd number of square tiles is needed to make the pattern. Is Derek right? And you must give reasons for your answer. Well, Derek is right. If you look at the number of squares in every odd pattern, In the first one, it's just 1, so that's definitely odd. But in the third pattern, pattern number 3, the number of squares is 3 times 3. In the fifth pattern, the next odd one, it's going to be 5 times 5. And then the next odd one will be 7 times 7. So you get the number of squares by multiplying the pattern number together. So in all of the odd ones, you're going to be multiplying an odd number by itself. In other words, an odd number multiplied by an odd number. And whenever you times an odd number by an odd number, you get an odd number as the answer. Okay? So you need to say something like, yes, the number of squares in an odd pattern number will be odd because odd times odd equals odd. Question 12. There are only 7 blue pens, 4 green pens and 6 red pens in a box. 1 pen is taken at random from the box and write down the probability that this pen is blue. So we need to work out the total number of pens in the box, which is just 7 add 4 add 6, which is 17. Then the number of blue pens, there are 7. It tells us that in the question. So the probability of choosing a blue pen is 7 out of 17. Question 13. The diagram shows a tree and a man. The man is of average height. The tree and the man are drawn to the same scale. Write down an estimate for the real height in meters of the man. Well, the average height for a man, I'm not sure exactly what it is. It's somewhere between, it's going to be somewhere around 1.7 meters, I would guess. A tall man is going to be 1.8 or even 1.9 meters. 1.9 is very tall. 1.8 is about 6 foot if you're used to dealing in sort of feet and inches. So I would say anywhere around that really. 1.6, 1.7, 1.8, 1.9, any of those answers would be absolutely fine. I'm going to go with 1.7. Then the second part, find an estimate for the real height in meters of the tree. What we're being asked to do here is to take our answer from the first part, I've said 1.7, and then work out how many times bigger the tree is than the man, and so multiply those two together. So you can see it looks like the tree is approximately 5 times taller than the man in that diagram. So the height of the tree is going to be 5 times bigger than 1.7. So 5 times 1.7. I'm using the grid method to do that here. 1 times 5 is 5. 0.7 times 5. Well, 7 times 5 is 35. So 0.7 times 5 is going to be 3.5. It's 10 times smaller, if you like, or we've moved that decimal point one place along. So if I add those two together, I get 8.5. So that tree is approximately 8.5 meters high. Question number 14. Year 9 students from Howell School were asked to choose one language to study. The table shows information about their choices and then draw an accurate pie chart to show this information. So the first thing to know about pie charts is that the circle is divided up into 360 degrees. You can think of it as just a pie that is being divided up into 360 slices. And we need to work out how many slices or how many degrees each person gets of that whole circle. So the way to do that, we need to find out how many people are included in this survey, first of all, and we just add up the total number of students. So 56, add 40, add 24, gives us 120. So there were 120 students that were asked about this. And they get to share those 360 degrees between them. We're going to split that circle up and share it between 120 people. So to work out how much of the circle they each get, we do 360 divided by 120. Like I say, you can think of it as I've got 360 slices of this pie and I've got to share it between 120 people. Well, they would each get 3 slices. Okay, so they each get 3 degrees of that circle. Then we need to work out how much of the circle each group gets. So the number of students who chose French, there were 56 of them. Each student gets 3 degrees of that circle. They get 3 slices each, okay? So 56 times 3 is 168. So that group, the French students, get 168 degrees of the circle. The second group, the Spanish, there were 40 of them, each of them getting 3 degrees. So 40 times 3 is 120. And then the final group, the German students, or the ones that chose German, there were 24 of them. Each student gets 3 degrees, so 24 times 3, and that's 72. Now, it's worth, at this stage, we know that they should all add up to 360 if we've done it correctly, so it's worth just checking that they do. So 168 and 120 add 72. We add all that up. That does give us 360. So we know that so far we're looking good. We haven't made an obvious mistake yet. The next part of the question is just about drawing that. So it's just about being able to use a protractor. Line the protractor up very, very carefully with the center of the protractor on the middle of the circle there, and with the line pointing straight up on the line that they've already drawn on the protractor. And we will count round from 0 round to 168, make a little mark, and then just join that up with that line. And then we'll just repeat that process. So we're going to turn the protractor around, making sure the center of the protractor is still on the center of the circle, and the line on the protractor at 0 is now going to be lined up with that new line that we've just drawn. Then you're going to count round from 0 round to 120 on your protractor, make a mark, and then join that line up as well. And then you finished at this stage, kind of, but it's worth checking. So that last chunk, the German, should be 72 degrees. So it's worth measuring it just to see how accurate you've been, and whether you made a sort of silly little mistake somehow with drawing your pie charts. The last thing then, before we completely finish, is to label each part of your pie chart, and you do need to do that. You will drop marks if you don't do that. So we've got the French part, then the Spanish part, and the German part. So the second part, we've got this new pie chart that we've been given, and this statement, Shamina says that the pie chart shows that French was chosen by more Year 9 students at Lowry School than at Hull School. Is Shamina right? And you must explain your answer. Well, we don't know how many students there are at Lowry School. It looks like French is more popular at Lowry School, but for all we know, there might only be 10 students at Lowry School. So that the number of people choosing French, there might only be, 6 of them. So no, Shamina isn't right, and we can't say because we don't know how many students are at Lowry School. Question 15. Here are a triangle and a rectangle. The area of the rectangle is 6 times the area of the triangle. Work out the width of the rectangle. Okay, let's first of all work out the area of that triangle. So to find the area of a triangle, you multiply the base times the height, and then you halve it. Or you might have been taught half base times height. It's the exact same thing, just in a slightly different order. So whichever way you're used to. I'm showing here 8 times 9 divided by 2, or over 2, as I've written it there. So 8 times 9 is 72. 72 divided by 2 is 36. So the area of that triangle is 36 centimeters squared. So then it tells us that the area of the rectangle is 6 times the area of the triangle. So we need to do 6 times 36. I'm using grid method there, so 36 across the top, 6 down the side. So 30 times 6 is 180. 6 times 6 is 36. If we add that together, we got 216. So the area of the rectangle is 216 square centimeters. So to find the area of that rectangle, we would have multiplied those two lengths together. So 16 centimeters multiplied by whatever that width is. And it's giving us an answer of 216 centimeters squared. So to work out what the width is, we just need to do 216 divided by 16 to work out what that missing number was. I'm using some short division here, the bus stop method. So how many 16s go into 2? Well, none. So I'm going to carry over that 2. So we now have 21. How many 16s go into 21? It's 1 with 5 left over. So we carry that 5 over. So we've got 56 now. How many 16s go into 56? Well, if we count up in 16s, 16, 32, and then 48. So that is 3. 3 16s will go into 56. And we have got 8 left over. So we're going into decimals now. So I'll put a decimal point above my line and below it, just after that 6. I'll put in a couple of zeros so we can keep going with this. And then I'll carry over that 8 there and I'll just put it in front of the 0. So the question now is how many 16s go into 80? And that is 5. If you count up in 16s, 5 of them make 80. So 13.5. So the width of the rectangle is 13.5 centimeters. Question 16. V equals U plus AT. And then it tells us values there. U is equal to 1, A is equal to -3, and T is equal to 1/2. And then it says work out the value of T. What we have to do here is substitute the values that we've been given, the numbers that we've been given, into that formula. So V is the bit that we're trying to work out. So V is equal to U. Well, we know that U is equal to 1. So we're just going to write a 1 instead of U. Add AT. AT just means A times T. And we're told that A is -3. So we're going to replace A with -3. And we're going to multiply that by T. And we're told that T is 1/2. So we end up with V is equal to 1, add -3 times 1/2. So thinking about BOD maths, we do that multiplication first. We do the -3 times 1/2. -3 times 1/2 is -1.5. So we now have V is equal to 1, add -1.5. If we're adding -1.5 to something, that's the same as taking away 1.5. So 1 add -1.5 gives us -1/2. Okay, so V is equal to -1/2. Question 17. 5 tins of soup have a total weight of 1,750 grams. 4 tins of soup and 3 packets of soup have a total weight of 1,490 grams. Work out the total weight of 3 tins of soup and 2 packets of soup. Okay, so we've been given some information in that question, and in particular that first line tells us that 5 tins of soup have a total weight of 1,750, and then in the second one it introduces the weight of packets of soup, but it doesn't actually tell us, so we're going to have to work that bit out. So first of all then, 5 tins of soup weigh 1,750 grams. Well, to work out the weight of 1 tin, which is what we want to do, we need to divide 1,750 by 5. I'm using short division here, the bus stop. So how many 5s going to 1 is none, so we carry that 1 over. How many 5s going to 17? It's 3. 3 5s are 15, so we've got 2 left over. Carry that 2 over, we now have 25. How many 5s going to 25? It's 5. How many 5s going to 0 is 0. So 1,750 divided by 5 is 350. So 1 tin weighs 350 grams. In that second part of the question, it talks about 4 tins of soup, the weight of 4 tins of soup. So let's work out the weight of 4 tins of soup. We've just got to do 350 times 4. I've used grid method there, so 300 times 4 is 1,200, 50 times 4 is 200. If we add those together, we've got 1,400. So 4 tins of soup weighs 1,400 grams. Now we can work out the weight of a packet of soup. So we've got, in the second part of the question there, it tells us that we have 3 packets of soup added to those 4 tins of soup. So we now know that the 4 tins weigh 1,400 grams. So if we do 1,490, take away the weight of the tins, in other words, take away 1,400 grams, we're left with 90 grams. And that is the weight of 3 packets of soup. So to find out the weight of 1 packet, we need to divide that by 3. So 90 divided by 3 is 30. So now we know the weight of 1 tin of soup is 1,400 grams. And we know the weight of 1 packet of soup, that's 30 grams. And it asks us to work out the total weight of 3 tins of soup and 2 packets of soup. So 3 tins of soup is going to be 350 times 3, which is going to be 1,050 grams. 2 packets of soup is going to be 2 times 30 grams, which is 60 grams. So if we add those two together, we get 1,110 grams in total, don't we? Question 18. Bellina has a garden in the shape of a circle of radius 10 meters. He's going to cover the garden with grass seed to make a lawn. grass seed is sold in boxes, and each box of grass seed will cover 46 square meters of garden. Belina wants to cover all the garden with grass seed. Work out an estimate for the number of boxes of grass seed Belina needs, and you must show your working. Right, so the key to this question is that it says to estimate. Okay, that means they want us to round off the numbers, not in the answer, but in the numbers that we use to find out the answer. So we've got a circle here. We're going to have to find out the area of that circle. So don't forget the formula for that, for the area of a circle, is pi r squared. Now this is a non-calculator paper and it tells us to estimate. So for pi, we're just going to round that off to 3. That's what it means when it talks about estimating. Okay, just use approximate figures. So pi is equal to 3. So to find out the area of the garden, we've got to do pi times 10 squared, because the radius of that circle is 10. And we're using 3 for pi, so we've got 3 times 10 squared, in other words. 10 squared is 100, so 3 times 100 is 300. So the area of the garden is 300 square meters. Each box of grass seed will cover 46 square meters of garden. Well, it's telling us to estimate, so let's round that off. 46 square meters rounds off to 50 square meters if we're just rounding off to one significant figure. So each box will do 50 square meters and the garden is 300 square meters. So if we do 300 square meters divided by 50 square meters, in other words, how many 50s will fit into 300? It's 6. So that's how many boxes of grass seed we need, 6. The second part of this question is your estimate for part A, an underestimate or an overestimate, and give a reason. Right. It is an underestimate, and the reason is the actual area of the garden is bigger than the area that we calculated, because pi is actually bigger than 3. It's 3.141 and so on. So had we done that accurately, the area of the garden would have been bigger. So that would suggest we're going to need more grass seed. But in addition to that, we said that each box of grass seed does 50 square meters, where in fact each box of grass seed doesn't do quite that much. So we're going to need more boxes of seed because our garden is bigger, and actually each box of seed covers less area than we used in calculating ours. So these questions can be quite hard to sort of figure out how are you going to say all of that in as concise a way as possible. And it's not easy, but really they're just looking for that to see that you understand what's going on. So I would say that it's an underestimate because the garden is larger than our estimate and each box of grass seed is smaller than our estimate. And that will be enough to get the mark for that. Question 19, solve 4 brackets x minus 5 is equal to 18. First thing with this, when I come across an equation with brackets, almost always the easiest thing to do, or the sensible first thing to do, is going to be to expand those brackets or to multiply out those brackets, okay? So I've got 4 times x, and then which is 4x, and then I've got 4 times negative 5, which is negative 20. Or you could think of it as you're just taking away 4 times 5. Either way, we end up with 4x minus 20 is equal to 18, and then we're going to go through and solve that equation. So the first thing I will do is to add 20 to both sides, which will give me 4x is equal to 38. And then I don't want 4 lots of x, I just want 1 lot. So I've got to divide both sides by 4. So I end up with x is equal to 9.5. Now, how did I get that 9.5? Well, there are different ways you could do this. You could use a bit of short division to do 38 divided by 4. What I often do, particularly when I'm solving equations, is I will write it like this. X is equal to 38 over 4. Still, that just means divided by 4, right? It's the same thing. And then I simplify that fraction down. So I can divide the top and the bottom by 2. So I can halve both of those, in other words. So x is equal to 19 over 2. And then I just think of it as 19 divided by 2. Well, I break that down even, actually. I think of it as half of 10 and half of 9. And then I add those two together. So half of 10 is 5. Half of 9 is 4.5. They add together to 9.5. Therefore, half of 19 is 9.5. The second part of this question, negative 3 is less than t, which is less than or equal to 2. T is an integer. Write down all the possible values of t. T is an integer. That just means it's a whole number. Okay, we don't have to write it as a fraction or with a decimal. It's just a whole number. So first thing, you need to know what those arrows mean. Okay, and the arrow pointing to the left means less than, and then the arrow pointing to the left with the line underneath just means less than or equal to. So our number, the t, well, -3 is less than our number. In other words, our number must be bigger than -3, but our number must be either less than 2 or equal to 2. I'm showing all of those numbers on that timeline there, all the numbers that could be included. That open circle means that I'm not including -3, but the closed circle means that I am including 2. It's not asking you to do that timeline. You don't have to do that. I'm just a way of sort of trying to show which numbers are included. So you can see all the numbers there are integers that are possible values of t. So -2, -1, 0, 1, and 2. Question 20. Asmal is paid £1,500 per month, or £1,500 per month. He is going to get a 3% increase in the amount of money he is paid. Work out how much money Asmal will be paid per month after the increase. Okay, so we need to find out 3% of £1,500 and add it on to what he's already been paid, the £1,500. So to find 3% of something, there are different ways you could do this. You could find 10% and then divide that by 10. Or you can go straight to finding 1% by dividing by 100. If you divide something by 100, you found 1% of it. So 1% of 1,500 is 1,500 divided by 100, which is £15. Okay, you could think of that as just moving that decimal point 2 places. So 1% is £15. Well, 3% is going to be 3 times that, 3 times 15. So 3 times £15 is £45. So 3% is £45. Here's the amount that he's going to be being paid per month now after the increase is, well, he's going to get an extra £45. So if we add that on, we get £1,545. Question 21. In fact, from here on in, these questions are from the higher paper. These are the first questions from the higher paper, as well as the last questions of this foundation paper. So we're into the harder questions now, definitely. So 21, the scattergraph shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. One of the points is an outlier. Write down the coordinates of this point. You can see most of the points sort of follow this trend. We've got that diagonal going from the bottom left up towards the top right. But there is one point that is sort of sticking out. It's all on its own, and that point, I'm showing it there, is what we call an outlier. It's not really following that trend. And the coordinates of that point are 10, 19. Don't forget, when you're writing coordinates, it's the one on the horizontal axis, the x-axis, going across, that you write first, and then the one on the y-axis. In this case, it's the axis with the temperature on, the going up axis, that you write second. So 10, 19. The second part, B, for all other points, write down the type of correlation. So when we have that trend going up from the bottom left up towards the top right like that, we say that is positive correlation. If it was going down the other way, sloping down like this, we call that negative correlation. And sometimes the points are just scattered around. There's no obvious kind of pattern, in which case we would say that there's no correlation. But this one, positive correlation. Part C, on the same day in another British town, the maximum temperature was 16.4 degrees centigrade. Estimate the number of hours of sunshine in this town on this day. So if we go back to the scattergraph, what we need to do to answer these questions is to draw a line of best fit. So that is a straight line that follows the trend of those points there. So we want it to be as closely as possible following the line of that slope, if you like. And ideally, you want as many points to be on the line as possible. So you want your line passing through as many points as you can, and with as many points either side of that line. So you've got to do that as accurately as you can. but in the mark scheme, they're aware that everyone's line is going to look slightly different. So there's a little bit of leeway there if you don't get it absolutely spot on, but obviously make it as accurate as you can. Then we need to go up to 16.4 degrees on our temperature axis. Now this can be a little bit tricky. We've got to work out what each of these little units are. So you can see I've marked on 11 there. So we've got 10, 11, 12. So there are 5 of those little small squares in between 10 and 11. So we've got 5 squares for one whole number. So each of those must be 0.2. If we do 1 divided by 5, that will give us 0.2. So it must be 10.2, 10.4, 10.6, 10.8, and then 11. Okay, that was just to show how I work out what those little small units are. Now we need to find out 16.4. So 16.2, 16.4 is there. And if we get a ruler and draw a line across, going from 16.4 until you hit your line of best fit. Once you've done that, you just need to get a ruler again and draw a straight line going down, and then read off the number of hours of sunshine that shows. Looks to me here like I've got 12.6 or 12.8, something like that. You should get something similar, but it might be slightly different, and that's fine, because as I say, in the mark scheme, they're aware that everyone's lines are going to look ever so slightly different, so you may end up with slightly different answers, but it should be somewhere around that. And then the final part, a weatherman says temperatures are higher on days when there is more sunshine. Does the scattergraph support what the weatherman says? Well, it does seem to, doesn't it? The days with more sunshine have a higher maximum temperature. Apart from that outlier, all the other points do seem to say that. So how are we going to answer it? Well, I would say yes. I would mention that there's positive correlation. So yes, there's positive correlation. There's more sunshine on days with higher temperatures. That should be enough to get us that mark. Question 22, express 26 as the product of its prime factors. Okay, we need to do a prime factor tree here. And this is where we look for a pair of numbers that multiply to 56, but we want one of those numbers to be a prime number. So don't forget your prime numbers. The first few prime numbers are 2, 3, 5, and 7. They keep going, but those are enough really to usually be able to do these prime factor trees. So I want a pair of numbers that multiply to 56 where one of them is a prime number. Well, I can do 2 times 28. That makes 56. I just halved it, in other words. So I write it like that. I circle the 2 because 2 was our prime number. I'm not going to touch that again. But I do repeat that process now with 28 because 28 isn't a prime number. Can I do 2 times something to make 28? Yeah, I can. I can do half of 28, which is 14. So 2 times 14 will make 28. Again, 2 is our prime number, so we circle that. We're not going to touch that. 14 isn't a prime number. It's an even number, so it's not going to be a prime number. And I look for a pair of factors that multiply to make 14, and I can do 2 times 7. And both of those are prime numbers. So I circle both of them, and when you get that situation, you're circling both of them, you know you are finished. So those numbers, the 2 and the 2 and the 2 and the 7, if we multiply those together, they make 56, and they are what we call the prime factors. So 2 times 2 times 2 times 7 is equal to 56. That is the answer, but we tend to write, instead of 2 times 2 times 2, we will say 2 cubed. So we end up with 2 cubed times 7. Question 23, work out 54.6 times 4.3. Okay. Lots of different ways you can do this. The way I tend to do it is to first of all just work out a rough estimate of what I think the answer is going to be. So I round those numbers off. So 54.6, I'll just round that off to 50, and 4.3, I'll just round that off to 4. So 50 times 4 is 200. So I know my answer is going to be roughly 200. It's going to be somewhere around there. And then when I work out the multiplication, I just ignore the decimal points. So I'm thinking of this as 546 times 43, and I do that just because I find it easier. I get less confused, I make fewer mistakes than when I try to calculate it using the decimals. If you've got a good method for doing it, using those decimals, then stick with that. If you've got that, that's brilliant. If not, have a think about doing it this way. I'm using the grid method to do the multiplication, but you could use any method you like, any method that you're comfortable with, that you consistently can do, without making mistakes. You stick with that. So I'm showing the grid method. So I've got 546 across the top, 43 down the side, and then I do all those bits of multiplication inside. So 500 times 40 is 20,000. 5 times 4 is 20, and then I've got those 3 zeros to add on. 40 times 40, well, 4 times 4 is 16. Then I've got those 2 zeros to add on from the 40 and the 40. 6 times 40, well, 6 times 4 is 24. I've got to add on that extra 0, so I get 240. If I repeat that for the bottom line, I get 1,500, 120, and 18. Then I've got to add all of those numbers together. You may have a particular way that you like to set this out. In this example, I'm just writing all the numbers, and I'm starting with the biggest number. Then I write the next biggest one underneath, and then the next biggest one, and so on, till I've got them all written down, and I'm just doing a bit of column addition there. So I've got the 8, and then a 7, and then I've got 14, so I carry that 1 over, then we get 3, and then 2. So we get 2, 3, 4, 7, 8. We've got to remind ourselves of where that decimal point is going to go. The answer needs to be approximately 200. So it's going to be 234.78. It's not going to be 23.478. That would be far too small. It's not going to be 2,347, for example. That would be way too big. Must be 234.78. Question 24. The area of square ABCD is 10 square centimeters. Show that x squared plus 6x is equal to 1. Okay, we're definitely into the tougher questions here, aren't we? What we're being asked to do is to find out the area of that square algebraically. In other words, using the measurements that they've given us, the 3 and the x square centimeters. And then we need to compare that with the area they've given us, which is 10 centimeters squared. So to find the area, you can do that different ways. I'm going to do it by breaking it down into each of those smaller parts. So we've got this first square, which has a width of 3 and a height of 3. So the area of that is 9 square centimeters. The area of this rectangle here, it's got a width of x and a height of 3. So to work out the area, we just multiply those two together. So 3 times x. And we just write that as 3x, don't we? Same for this other rectangle here. It's got a height of x and a width of 3. So we do 3 times x, which is just 3x again. And then finally, we've got that small square there, which is x times x. And we write that as x squared. If we add all of that lot together and simplify it, then we get x squared, add 6x, add 9. That is the area of the square algebraically. But they have told us that the area is equal to 10 square centimeters. So we could say that x squared plus 6x plus 9 is equal to 10. Right? Those two things are the same. They're just different ways of describing the area of that square. Now, it almost looks like what they've asked us. They say to show that x squared plus 6x is equal to 1. You can see those two things look very similar. If I took 9 away from that right-hand side, that would then just give me 1 on the right-hand side. But of course, it's an equation, so we would have to subtract 9 from both sides. If we do that, then we are left with x squared plus 6x equals 1. And we are done. We've shown that those two things are equal to each other. Question 25. This rectangular frame is made from 5 straight pieces of metal. The weight of the metal is 1.5 kilograms per meter. Work out the total weight of the metal in the frame. Right, well, first of all, we need to work out how the length of all the pieces of metal in the frame. So going around the outside there, the perimeter of that rectangle, we've got 5 meters, add 12 meters, and then that other side is not marked, but that's going to be 5 meters as well. And then the other one, which is also going to be 12 meters, if we add that lot up, we get 34 meters. So we've got 34 meters of metal going around the outside, but we've also got that diagonal. People often get caught out at this stage because they don't know how to find out the length of that diagonal. It's much easier if you kind of ignore the top two lengths, or the left-hand side and the topmost part of that rectangle, and just think of it as a triangle. And we've got the diagonal of that triangle is obviously the same as the diagonal of that rectangle. And we can use Pythagoras' theorem to help us find missing lengths of a triangle. And that's exactly what we're trying to do here. So just a reminder, Pythagoras' theorem is that a squared add b squared is equal to c squared. So c is the length that we're trying to find out in this case. So let's mark those as we've got 12 meters and 5 meters. So we need to do 12 squared add 5 squared, and that will give us c squared. So 12 squared is 144, 5 squared is 25. That will tell us what c squared is. So that's 169. So c squared is 169. That is c squared. In other words, when we multiply c by itself, we want to find out what c is. So we do the square root of that. Square root of 169 then is 13. So c is 13. Now we can calculate the total length. It's the 34 meters around the outside. Add those 13 meters, which gives us 47 meters. And then we need to find out the total weight. So we've got to do 47 times 1.5. As ever, there are different ways you can do this. I'm ignoring the decimal point. I'm doing 47 times 15. I'm using the grid method to do that. So I've got 470, 235, which all adds together to make 705. Then I need to move my decimal point back one place because it was 47 times 1.5, not 47 times 15. So 70.5 then is the final answer there. Question 26, the equation of line L1 is y equals 3x minus 2, and the equation of line L2 is 3y minus 9x plus 5 is equal to 0. Show that these two lines are parallel. Right, this is all to do with graphs of equations, and that is to do with y equals mx plus c. That is just the general way that we describe the graph of an equation, and that m, the letter m there, is the bit that represents the gradient. In other words, how steep the line is. Okay, so I've made a note of that there. Also, we need to know if you have two parallel lines, they are the same steepness, aren't they? In other words, they will have the same gradient. And that is the key to this question. We need to show that both of those equations have the same gradient. If we do that, then we have shown that they are parallel. That first equation, L1, you can see that the gradient is 3, okay? Because that m is just the number of x's, isn't it? In this case, we've got 3x, so the gradient is 3. The second equation, annoyingly, is arranged in a different way, isn't it? It doesn't look the same. It's not in that form of y equals, some x's and then add a number. So we need to rearrange that second one. We just want the y all on its own on the left-hand side. So if we add 9x, first of all, to both sides, on the left-hand side, then we end up with 3y plus 5. And on the right-hand side, we end up with 9x. Then let's remove that 5. So let's subtract 5 from both sides. So we end up with 3y is equal to 9x minus 5. And then I don't want 3 lots of y. I just want 1 lot of y. So I've got to divide by 3. So if I divide 3y by 3, I just get y. But then I've got to divide everything on that right-hand side by 3 as well. So 9x divided by 3 is 3x. And then I've got that negative 5 divided by 3. I'm just going to write it like that, minus 5 over 3. From that, now this is in that same format, isn't it? Y equals mx plus c. So the gradient of this one is also 3. There are 3 lots of x, in other words. So both these lines have a gradient of 3. I would put a little note to the examiner that they are parallel because they both have the same gradient. And you are done with that question. Question 27, the final question, and it's all to do with vectors. And I think these vector questions are actually quite doable. Considering it's the last question in the paper, I think they're not that bad and worth a bit of practice on, definitely if you're trying to get those higher grades of this foundation paper. Right then, so ABCD is a parallelogram. The diagonals of the parallelogram intersect at O, and OA, or we could say vector OA, is equal to A, vector OB is equal to B, and then question A, find in terms of B the vector DB. Okay, now, it's not the most mathematically accurate description, but you could think of vectors as just a road. or the name of a road. So it says that OA, in other words, the journey from the center of that parallelogram to A, there is a road there, and the road has a name, and that is A. Similarly, to go from O to B, the name of that road is B. And the question is asking us to find DB. In other words, what's the name of the road that goes from D to B? Well, we would need to put two of those B's together. So if we did D to O, that would be a B. Then O to B is another B. So kind of two roads that are both B's. So we would just describe that as 2B. The second part, find in terms of A and B the vector AB. Okay, now you can see there's that straight line going across the top that connects A and B, but we don't have a name for it. There's no letter describing that journey. So what we would need to do, we can only use the roads that we know the name of. So we would need to go from A to O, back to the center, and then from O to B. So from A to O, we've got that letter A there, but can you see the arrow is pointing in the direction from O going up towards A, which is the opposite direction that we're going. So we're going back from A to O, so we would describe that as negative A. When you're going in the opposite direction to the arrow, it becomes a negative. So we are going from A to B, so we've got negative A, and then we go along that road, which is B. So negative A add B is our answer. And in part C, find in terms of A and B the vector AD. AD, we would need to go from A to O, which is negative A, and then from O to D. Well, D to O is just B, so we go back in the other direction, so that would be negative B. So negative A add negative B, which actually you can just write as negative A, take away B. And that is it, you're done. Final question of the paper. Well done if you got that, and if that made sense. Thank you very much for watching this. I hope it was useful. I will be putting videos like this up as regularly as possible. So do subscribe, do give the video a like if it was helpful, and I shall see you in another one.